this video, I'm going to talk about worksheet 7-5 and go over the answers for number 2 and number 3. So, going back to number 2, I have drawn the diagram that they give us in the book. This problem is easier than it looks, but I understand why it was difficult for some of you. So hopefully this video helps. So the first thing I want to do is talk about how to figure out the angle A, which is just this angle right here, right? Alright, so with any polygon, we know that the inside, well, a regular polygon, meaning all the sides are the same length, we know that the inside, all of the angles on the inside, are going to equal 360 degrees. So if we were to draw a line here, a line here, a line here, a line here, all of these angles together that make up the tip of the pizza slices would add up to 360 degrees. Now, since it's a regular polygon, we also know that they're all the same angle. So what we can do is look at the shape that we have. We know we have 1, 2, 3, 4, 5, 6 interior angles made by the radii of this polygon. So what we can do is take 360 divided by 6, which is 60 degrees, and we can assume that angle A is 60 degrees. So once we have that done, I'm going to write that answer up here. A equals 60 degrees. I'm just going to erase this stuff off of my diagram so I can focus on what we're working on next. So all of these things I just drew in to help me visualize what's going on. Alright, so now we're trying to solve for C. I thought that we had D. Oh yes, we do have D out here. D is out here. Okay, we're trying to solve for C and D. Now what we need to do is create somehow a triangle that we can work with one side that we know. So one thing that is true about the apophthegms is that you can draw an apophthegm from the center of the polygon to the middle of any of the sides, and they are all going to be the same distance. So we could draw an apophthegm here and assume that it was 4. We could draw it here, it's 4. Here, it's 4. Here, it's 4. Boom. Now we have a triangle we can work with. So we don't need all of these other ones that I drew. That was just to explain. We can leave those out of the image now. In fact, we don't even need the one that they gave us. So we are going to use this triangle. You can use either side, but we're going to use side C. So I'm going to take this triangle right here and just draw it bigger out here, because it's the only thing I need to figure out these side lengths. Okay. Okay. So we know it's a 90-degree angle. Now we also knew that this angle up here was 60 degrees. So we just cut it in half. So we know that this angle is 30 degrees. This one right here. The top is 30 degrees. We know that this is 90 degrees. So for it to be a triangle, for all the different angles inside the triangle to add up to 180 like they need to, this would be a 60-degree angle. Okay, so that means it's a 60, 30, 90-degree triangle. So we can use the 30, 60, 90-degree triangle theorem to solve for the missing sides. Alright, so I don't need that information anymore. I know I'll use the formulas given in that theorem. Okay, so we don't know side C. We know this is 4. And we know this length is D, so that means this is D, this is D, this is D, this is D, and this whole thing is D, but we only need half of it. So I'm going to say that this length is D over 2. It's 1/2 of it, right? Okay, so this triangle is what we have to work with to solve for C and D. In other words, I don't need this anymore, so I'm going to erase it so I don't get distracted and I'll have more space to write. Okay. So we have, I'm not going to redo this video just because of that. I hope you enjoy. Okay. We have the long leg. We don't have all of the short leg, but we have something for it. And we don't have the hypotenuse. What we can remember from the theorem, though, is that the hypotenuse equals 2 times the short leg. I'm going to put SL so I don't have to write it all out. And we know the long leg equals the short leg times the square root of 3. That's what we know from the theorem about 30, 60, 90 degree triangles. So let's use that to solve. All right, let's start with, we have to start with one where we know the number as part of the formula. So we have to start with the second one because the only thing we know is the long leg. And that's not part of the top formula. So let's start with that. We'll plug in the 4 equals short leg times the square root of 3. And now we can plug in the short leg, which is d over 2. So 4 equals d over 2 times the square root of 3. And now we need to get d by itself. So we can solve for d with this. It's a little bit tricky, but we can do it. So we need to divide each side by 3. So that means we have 4 over the square root of 3 equals d over 2 times the square root of 3 over the square root of 3, which basically just cancels out this square root of 3 on this side. So d over 2, or 4 over the square root of 3 equals d over 2. Now we need to get d by itself, so we're going to take both sides times 2 to get rid of this 2 on the bottom. So moving that over here, we now have 8 over the square root of 3 equals d. Okay. Make sure you have all of that. I'm going to move back up here and use some of this space. We can't leave the square root of 3 on the bottom. It's not a real number, so we have to get rid of that. So anytime you need to get rid of the square root on the bottom, you take the number with the square root in it and take it times that square root over that same square root, like this. So you can take 8 over the square root of 3 times the square root of 3 over the square root of 3. Now, the square root of 3 over the square root of 3 is just 1, so it doesn't mean anything. So you're not going to mess up your equation by doing this. You're going to solve it. So when you take the square root of 3 times the square root of 3, it becomes 3. So the bottom is 3, and the top is 8 times the square root of 3. And that is our answer. D equals 8 times the square root of 3 over 3. So I'll write that up there. Okay, erasing all of this now. And I'll put it into my diagram so I can visualize that. So the short leg is 8 times the square root of 3 over 3. Okay, now the hypotenuse is C here. So I'm going to write C. I'm going to use this top one now, plug in everything I know. So C equals 2 times, oh, I solved for D and forgot one second. I solved for D and forgot that this short leg is actually this divided by 2. Now I don't necessarily need to figure out what that is, but the short leg is this. So basically, I need to write that the hypotenuse is 2 times, this is going to look kind of funny, 8 times the square root of 3 over 3 over 2. Because that's the length of this little side. If you remember, d over 2 was the length of the short leg. So once I solved for d, I need to divide that by 2 still. I don't want to actually do that work because it's not going to be necessary because we just happen to have something that cancels out here. So this 2 cancels out with this 2 because this 2 would technically be over the 1. So they cancel each other out and we are left with c equals 8 times the square root of 3 over 3. So that is c. C and d happen to be the same because this short length was d over 2 and this was d over 2 times 2, so they ended up being the same answer. But anyway, there's the answer for number 2. I would say that was the hardest one on the worksheet, so if you had trouble with it, don't feel bad. I'm going to do number 3 now. Okay, so number 3 is a little bit easier, but it's very similar to number 2. Anyway, so we have another hexagon. And the first thing, you might remember doing this with number 2, so you might not really have to do any math, but we need to figure out what this angle is, angle x. So if you remember, all of the interior angles of a polygon add up to 360. If you have a hexagon, you're going to divide it by the number of sides. So if you have a hexagon, it's going to be divided by 6. So each of these larger angles is going to be 60 degrees. But x is half of that. So x equals 30 degrees. So we can be done with that. That part is pretty easy in comparison to other parts that we have to do. Oh, that was the one that I needed to leave. Just kidding. Okay. There we go. Alright, now we have a little triangle here. So that's what we're going to pull out and use. I'm going to draw it here. That's not a 90-degree triangle, but we're going to make it that way with our markings. Alright, so we know that this angle is 30 degrees because we just established that x equals 30. So it's a 30, 60, 90-degree triangle. You probably got that far. So we're going to use the same formulas that we've been using for numbers 1 and 2. Okay, so the length of this is the same as the apothem, which is p, labeled p. Alright, and let's see. Oh, we also, I always forget this. We have this side is called q. Alright, we know all of the sides are congruent, so we can say that this side is also q. So we're going to have to do something similar where, alright, this side is q, well, this little bit here is q divided by 2 then. So we're going to have q over 2. Okay? And then for this side, alright, here's a radius. All the radii that go around it are all the same length. So this one's going to be 8 as well. These two are congruent. So we know that the hypotenuse is 8. Okay? So this is what we're going to be working with our 30, 60, 90 theorem formulas. Okay, like I said before, the hypotenuse equals 2 times the short leg, and the long leg equals the short leg times the square root of 3. Now we need to do the one with the hypotenuse first this time because we have a number for the hypotenuse, so we'll be able to solve it. So I'm going to use this one first this time. So I'm going to put in 8 equals 2 times q over 2. Just to make this a little easier for myself, I'm going to put a 1 under here, so I know it's 2q over 2. 8 equals 2q over 2. Okay, further simplify, we can cancel this 2 out by multiplying both sides by 2, so 16 equals 2q. Now to get the q by itself, we have to go back again and divide both sides by 2, so we have 8 equals q. So q equals 8. And we have one more we need to solve for p. So I'm going to put this q equals 8. Oh, 8 over 2, we can just assume that that is 4. That short side is 4. This time we can easily reduce it and